Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Syuhada binti Muhammad Azami. Okay, let's continue with what is differentiation. In mathematics, differentiation is process of finding the rate of change of a function. The practical technique of differentiation can be carried out by purely algebraic manipulation with three basic derivatives, 4 rules of operation, and a knowledge of how to manipulate function. Okay, this is the three basic derivatives. First is for algebraic function, which is dx power of n equal to nx power of n minus 1, in which n is any real number. And second, for trigonometric function, which is d sin x equal to cos x and d cos x equal to negative sin x. And third is for exponential function, which is d e power of x equal to e power of x. Okay, next, this is the core rule of differentiation. First rule is sum rule, which is d over dx fx plus with d over dx gx. Second is difference rule, which is d over dx fx minus with d over dx gx. And third is constant multiply rule, which is k multiplied with d over dx fx. And the last one is constant rule, which is d over dx multiplied with k equal to 0.
Hi, Assalamualaikum. My name is Ainur Sofia Arena binti Hazarai. For my part, I'm going to explain why we use differentiation. So, differentiation allows us to find rates of change. For example, it allows us to find the rate of change of velocity with respect to the time, which is an acceleration. It also lets us to find the rate of change of x with respect to the y, which on a graph of y against x is the gradient of the curve. This is because the derivative provides information about the gradient or slope of the graph of a function. We can use it to locate points on the graph where the gradient is 0. We can also check the local minimum and maximum point using the second derivative test by considering the value of second derivative.
Hi and Assalamualaikum. My name is Siti Aisyah binti Abdul Jamal, and I will continue this video with application of differentiation in real life. The first one is to calculate the profit and loss in business using graph. This allows us to examine how revenue and cost change at the quantity produced and sold change. Next, to determine the speed or distance covered, such as miles per hour or kilometer per hour. Then, derivative are used to derive many equations in physics. In physics, acceleration is the rate of change of velocity. So, acceleration is the derivative of velocity. Finally, in the study of seismology, derivative is used to define the range of magnitude of the earthquake. In this work, fractional derivatives are used to define the 1D viscoelastic constitutive law for granular dry soils and frequency domain the seismic wave propagation under strictly linear and linear equivalent condition. That's all from me. My team member will continue with the next slide.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Nadia binti Muhammad Zaid, and my matrix number is 202048796. So here, this is my part that I will present. That is, what is differentiation problem? In this picture, we have given that figure below shows a piece of wire length 200 cm is bent into the shape of triangle ABF and rectangle CDEF as shown. Given that BC is equal to DE. So BC is 3y and DE also 3y. So the question 1 express as in terms of y. Question 2 show that the area A cm square enclosed by the wire is A equal to 378y minus 12y square. And third, find the maximum area enclosed. So how to solve this problem? The question 1 expressed as in terms of y. So we have given that the perimeter is 200 cm. So we just add this number in the equation and equal with 200 cm. And we have to express s in terms of y. And finally we get that s equal to 59 minus 2y. So the question 2 show the area A cm square enclosed by the wire is A equal to 378y minus 12y square. So we have to divide into two pictures. So this is triangle and this is rectangle. So in this triangle, 1 over 2 times x times 6y and we get 3xy. And in this rectangle, we have to times x plus 8 times with 3y and we get 3xy plus 34y. So we have to combine these two equations in one full equation of area. So we also have to add the value of x that we get in the question 1, that is 59 minus 2y. So we have to add the x in this equation. And finally we get the area, that is 378y minus 12y squared. And this is a proof because this answer is same like the question. So number 3, find the maximum area enclosed. So the first step is we have to find the derivative. So the equation area just now we have to find the derivative and we get the negative 34y plus 378. Second step is we have to let the derivative equal to 0. So we get the value of y, that is 15.75 centimeter. So the third step is we have to find second derivative test. So in this second derivative test, we have to see that the area that the value that we get is less than 0 or more than 0. If the value is less than 0, it will be the maximum value. But if the value is more than 0, it will be the minimum value. So in this case, we get negative 24, so it is in maximum value. So we have to find the maximum area of shape. So in this question, we just put the value of y in this equation, and finally we get the A equal to 2976.75 cm square. So that's all for me, my friends. We continue with the conclusion. Thank you.
We have come to the end of this discussion. As a conclusion, we can solve this problem by using a differentiation method. By using this method, we are able to find maximum area enclosed, the equation we have solved before, which is maximum area of the shape equal to 2976.75 square centimeter. In order to calculate the rate of change, the application of the differentiation is applied. We can accurately count the differences in change happen. As a whole, the concept of differentiation can be used in our daily life to solve problems. So that's all from our group. Thank you.